Hey, fourth graders, what's up? It's Mr. Peters again with our quiz from last week on multiplication. Once again, so with this one, it's really some of the skills and strategies that we really want you guys to be secure on before you leave fourth grade. So if you still aren't 100% confident on some of these, that's something that you could work on over the summer if you're looking for some extra practice. All right, so looking at our first problem here, we have solve using an efficient multiplication strategy. 37 times 8. So one of the first things that we want to do when we're doing a multiplication problem, and well, really any math problem, is kind of wrap our heads around what's a good answer. Okay, and so kind of like a good answer would be, or a way to do it or find it would be check with rounding and things like that. So if I was going to round 8 times 37, there's a few different ways I could do it. The one that I would do is I would round 37 up to 40. And so if I rounded 37 up to 40, I would have 8 times 40 instead as my problem right now. And 8 times 40 would be 320 because 8 times 4 is 32, and we've got 10 times bigger. So I rounded up, so I know my answer has to be a little bit less than 320 in somewhere. So if I'm looking at my two options here, or 4 options here, 2 I can get rid of right away would be 396 and 29. Those ones aren't even close, so those don't make sense. Get rid of them. So going back here, now we have 296 and 287. So if I was going to solve this problem, quick, easy way would be doing our area model. So we said 30 and 7. So split it apart right there. 8 times 30 is 240. Once again, I know that because I know 8 times 3 is 24. And so once again, it's 10 times bigger. Whenever you're multiplying by a number that ends with a 0, it's a multiple of 10, so you can move it over. 8 times 7 then is 56, and I simply add those together. 240 plus 56 is 296. And that is somewhat close to our guesstimate of 320. 296 is our answer for that one. Now jumping to our next problem, 9 times 32. Once again, I would do a guesstimate here, and you could do a few different ways. You could round the 32 down to 30, or you could simply do 10 times 32, which we should all know is 320. And so we just rounded the 9 up. So our answer's got to be a little bit less than 320. Now when I say a little bit less, when you're dealing with big numbers like that, a little bit could still be 20 or 30 away, right? But looking at our answers here, we can still eliminate 2 of them. Okay, we have 320 as our guesstimate. We can get rid of 488. That's nowhere close. And we can get rid of 28. That's nowhere close as well. And once again, if I look at this, I'd probably use my strategy here again and do 30 and 2. And times 9. So once again, 9 times 30. On this one, if you weren't sure, you could do times 10. And then go down a set. But 9 times 3 was 27. And so I know that it has to be 270 because I moved the 27 over, and then I filled that spot with a 0. And then 9 times 2 is simply 18. Put it together. We get 288. And there it is. Question number 3. Solve using an efficient strategy. 143 times 7. All right, so once again, for just looking at, there's 2 answers that we know we should get rid of right away. 101 and 11. They're both smaller than one of the numbers. We're multiplying with whole numbers. When you multiply with whole positive numbers, your answer always has to get bigger. If you're multiplying with a decimal or a negative number, your number could change and go less. But right now, since we're multiplying with whole positive numbers, it has to get bigger. So 101 and 11 would not be possible. So now looking at these, we said 143 times 7. Let me just double check. Yep. Okay. So a few different ways that we can do this. We could do our area model again and split it apart. Or since we were just working on algorithm the other day, I'm going to do that one for this. Let me change my color so I can show my thinking. 7 times 3. Once again, we start on that right-hand side, just like you do for addition. 7 times 3 is 21. So I put my 1, carry my 2. Then 7 times 4 is going to be 28. Plus my 2 would be 30. So put my 0 down there and carry my 3. 7 times 1 is 7. Plus the 3 is 10. Technically, the 1 would go up there, but we're going to bring it right down, and we get to 1001 for this one. And it's there. Solve using an efficient multiplication strategy, 28 times 16. Once again, if we're looking at it, one that we can get rid of right away, 48. Doesn't make sense, way too small. The rest of these, they're actually somewhat close to each other, so we're going to leave them all as options for now. So 16 times 28. Okay, we could do it a few different ways here. I could do the algorithm. I could do one like that. There's a lot of opportunities here for us. And lucky for you, I'm going to show you both because I want you to be able to see both ones here. So starting with our algorithm here, once again, we are going to start over on this side. You start on that right-hand side. Okay, so 6 times 8 is 48. Now, just like with addition, when your number is 2 digits, when your answer is, you have to carry that other digit up. Because that 4 is actually in the tens place now. Now we're doing 6 times 2. And that 2 is in, it's actually 20, but the nice thing with the algorithm is that we get to treat it as if it's a single digit. Okay, so 6 times 2 is 12. Plus our 4 is going to be 16. Okay. And so with this one, sorry, I was thinking about something else for a second. So with this one, 6 times 2 we said was 12, plus the 4 is 16. And so we can put our 6 and then our 1. But the way that we can look at it here is if we did the 6 times the 20, well, 6 times 20 is 120. Plus our 4 in the tens place, which is worth 40. 120 plus 40 is going to be 160. So once again, we get to treat it as if it's just single-digit multiplication. That's the nice thing about it. You have to remember some of the little tricks and kind of patterns of it. That's the tricky part of it, right? So there you may have noticed I erased the number on the top to show my new thinking. And then the next part, we're moving over to the tens place with our 1 here. So automatically, if we're multiplying by something in the tens, or a multiple of 10, it has to end with 0. So you put your 0 there as your space saver, and we automatically know because this we get to treat it now as single digit. 1 times 8 is going to be 8. But really, that 1 was actually 10. So 8 times 10, that's 80. That's why we have our 80 here. But we got to treat it as a 1. Then 1 times 2 is 2. And now we have all of our multiplication done, and we can simply do, our addition here to add it up. 8 plus 0 is 8. 8 plus 6 is 14. Carry my 1. 1 plus 1 plus 2 is 4. 448. Let's double check. 448 is an option here. And then let's quickly check this one. 10 times 20 is going to be 200. 8 times 10 is going to be 80. 6 times 20 is going to be 120. 6 times 8 is going to be 48. So right away, the two that I'd add together would be 120 and 80 because I know that makes a nice big friendly 100. So that's 200 right here. Plus the 200 here is 400. Plus the 48 equals 448 for us. And sorry about that. Which fraction is equivalent to 3/4? All right, so looking at our fractions here, a few things that we want to do. Remember, with equivalent fractions, you have to see if they can be multiplied to the other denominator. Now, one of the things we can see right here, we can't switch 3/4 to 2/3. I can't divide 4 by a number and get down to 3 or a whole number. Same thing with our 2/3. It wouldn't work. Same part here with our 5. It wouldn't work. 4 times no whole number is going to be 5. Same thing here. We can't do that. Now, when we look over here, well, we could change the 3 into 30. 3 times 10 is 30. But 4 times 10 is going to be 40. So that'd be 30/40ths would be the equivalent fraction here. So what we want to do is look at 9/12. We've eliminated the other ones. Now we need to prove 9/12 works. So 3/4. And our target that we're trying to change it to is 9/12. So you want to be asking yourself, what can I multiply 3 by to get up to 9 or 4 by to get up to 12? So if we know our facts, 3 times 3 equals 9. And we need to ask ourselves, does 4 times 3 equal 12? If it does, we're correct. And it is. So we are good to go on that one. Okay, so remember, with these multiplication strategies, there's not necessarily one best option every problem. It's up to you to figure out what works well for you, and then also what makes sense to use with the problems. But one of the first things that you do want to try to make sure you do each time is make sure that you have an estimate in mind before you solve the problem or before you dive into it, because that's going to help eliminate some of the really silly mistakes that you might make along the way. All right, good luck, guys.